You're really too loud. All right, you ready? How about the antiderivative of sine cubed I've been smoking in Marlboro Reds. X times cosine squared of x. It's very difficult to write with a mouse, especially when you got a little mouse pad like this. This thing has electrocuted me several times. All right, done yet? Just do the first times derivative of the second plus the second times derivative of the first. Just do that. Mr. Fowler, I'm glad to see you, sir.
Likewise.
And yes, you will use trig identities. I would rewrite the problem first. Maybe something like this. That might help you a little bit because that's a whole lot easier to work with. And that's the derivative of that, isn't it? Well, not cosine squared, but what's the derivative of cosine? Right? Or the negative sign. So now you're looking for that fourth bolt. The reason this is a good problem for a test is because it kind of gives you reason for doing these type problems, because you can actually see to take a problem and just rewrite it and manipulate it so you can get the answer. Nobody's ever going to walk up to you and ask you what the antiderivative of sine is. Sine, nobody's going to ever ask you that. But people will ask you to look at a problem and break it down several different ways, whether it's a bridge or whether it's a research problem or whether it's a finance problem. And you can either break it down into several different parts or you can tell them you quit. how can you rewrite the sine squared? And I would put that in parentheses. And then I would put this in parentheses. Why do you want to keep this together right here? Why do you want to keep that together? Because it's u du. And if you could make this go across this, then you would have u du minus u du, some kind of form of u du. And that's what you want in a lot of these problems. You want to find some kind of u du pattern to it. That's what you want to find. Now what could I do now? Distribute what? I would distribute this. Well, distribute one, the other, it doesn't matter. And that would give you the antiderivative of cosine squared sine x minus cosine to the fourth x sine of x dx. Now finish it out. Now, if u is equal to the cosine, du is equal to the what? Negative sign? We don't have a negative sign, so that means you've got to what? Huh? Put a negative out front. So don't forget to do that. So break it up. In fact, I'll just take this for the next page. And we'll get the antiderivative, cosine squared of x, sine of x, dx, minus the antiderivative of cosine fourth of x, sine of x, dx. So if I make u equal to cosine of x, then du is equal to the negative sine. what is that going to put out front here? It's going to put a negative, and it's going to make this a what? Positive. And then you'll have negative antiderivative of u squared du plus antiderivative of u to the fourth du. And that'll give you negative u to the third over 3 plus u to the fifth over 5 plus c, and u is what? Cosine cube x over 3 plus cosine fifth x over 5 plus what? Now you can bring the 1/3 out. You can do that, and 1/5. That's fine. Manipulation with a capital M. See if I can find one in your book. Where I got that one, probably out of the old book. Okay. Alright, this time y'all do cosine squared tangent cubed. Cosine squared tangent cubed. It's number 17 in your book. Let's see if I can snip it like y'all taught me how to do. Let's see, 17. Gotta find the page turner. Where is it? I appreciate the heck out of that. That saved me a lot of time. Who showed me that? Huh? Well, y'all gonna give y'all extra A. No, I'm just kidding. Let's see if I can muster up some bonus points somewhere. Let's see, downloads. I used it all day yesterday. Cosine squared of x, tangent cubed. Now this one, I would probably use your reciprocal identities. Do y'all remember in trig when the teacher was supposed to tell you, hopefully they did, that whenever you can, try to get everything in terms of sine and cosine? You remember that? Well, that still holds true. Help y'all out again. Trig identities. Let's see if I can pull this off again. I'm just going to just start snipping in the whole class. That's what I would use.
It really has changed your life.
It has. It really has. See, I didn't know I could do that. And it helps y'all too, because y'all don't have to remember as much. Now, if you want to go backwards, then change the cosine to 1 over secant. Now, that would be going backwards. That would be tightening the bolts on your starter instead of what? Loosening them. Or breaking them off into the block. Yeah. That would be going backwards. You could pull the starter out, but then you have to weld nuts onto the... and you know that weld ain't going to hold. Listen, I have too. We had the rock guards and the roller bolts on the D6 on the farm just shear off, and they were sheared off flush with the track. And I had to get under there this far from the ground. I had to cut the rods and take a 15/16 bolt and hold it with a pair of vice grips and put it right there and weld it to the bolt. It took me about 3 or 4 weeks to get all them bolts out. I got about 12 out. To this day, every other time I run that D6, I make sure the bolts are tight so they don't shear off. Because I don't want to, if I have to do that again, I'm going to sell the dozer. I'm not doing it again. So what could we change that tangent to? Yep. You could also, yeah, sine over cosine would be the best one. Then see what you get. So, dang old antiderivative of the cosine squared of x over 1 times, and we'll change that tangent to sine cubed over what? Cosine cubed. And that's going to give us the antiderivative of cosine squared x sine cubed x over cosine cubed x dx. And dang what happens to the cosines? Cancel, and you get the antiderivative of sine cubed of x over the cosine of x dx. Dang what is that? Y'all supposed to be saying something. That's not rhetorical. Just forget about the cube. Forget about that. No, sine over cosine. You got to take the integration. You got to do the antiderivative. So you're looking for what pattern? I said it a while ago. U du. Now you got to look for some kind of pattern of u du. What do you see? Huh? The fu.
You take the u sine the cosine.
So what do you have? You have, and what is that? Huh?
I mean, you can't solve it when it's 1 over.
Keep doing what you were thinking before that. Du over u, u over du, du over u. That rings a bell. U over du, or du over u. Which one is it? What is that? That's it, huh? Well, keep going with that. You're going to keep going with it. You're getting there.
What I did, I just took sine and multiplied by sine squared x.
You took what now?
Sine x times sine squared x. Then substitute sine squared x for 1 minus cosine squared x.
Yeah, you could do that. That would work. I think it would, yeah. Finish it out. Natural log is in the answer. You could, are you talking about changing the sine cubed into sine squared times sine? Is that what you just said? Yeah. That would work. Just like you did in the previous. But you've got some form of u du going is what I'm trying to get across to you. And that's what you want to get. So I would change what 1 minus the cosine. The sine squared is 1 minus the cosine. And then work it out. So this is going to give you the antiderivative of sine squared of x times sine of x over cosine of x. I don't know why I'm going to write the x up in the exponent. Dx. And sine squared of x is 1 minus the cosine So we could rewrite this as 1 minus the cosine. So
antiderivative of 1 minus cosine squared of x times sine of x over cosine of x dx. Distribute the sine of x minus sine cosine squared of x over cosine of x. And now you can put it over the common denominator. I didn't give up on it. I just do whatever it copies. And that's going to give you the antiderivative of the sine of x over the cosine of x minus the antiderivative dx minus the antiderivative of the cosine squared of x sine of x dx over cosine of x. And you can take these two, and what can you do here? That's a square. You can't read it. Antiderivative of the sine of x over cosine of x dx minus, and what happens here? You get cosine of x times what? Sine of x dx. Make sure I hadn't made a mistake. Now what do you have? That u equals to the cosine, and if u is equal to the cosine of x, what's du? Negative sine of x. So we know, again, we need to take our red marker, and that'll put a negative out here and a positive here. And here we have du over u plus the antiderivative of u du. And what is this? Negative natural log of u plus, what is this? U squared over 2 plus c. And now, u is equal to the cosine, negative natural log of the cosine of x plus cosine squared of x over 2 plus c. Manipulation, rewriting. Let's try this one. Anybody got that one? You feel good about yourself? Feel confident? Y'all don't lie, do you? Antiderivative pi over 6, pi over 3. I don't want y'all to forget the tedious mathematics. Of cosine cubed of x over what's the first thing you're going to do? Well, before you do any rewriting, what should you do with that radical? Change it into an exponent and bring it upstairs. Because that way you'll have u du. And then do what you're talking about doing. And change, like you said, the cosine to cosine squared times cosine. These are kind of like what? Puzzles. So if you suck at puzzles, chances are you're going to suck at these. Trying to discourage you a little bit more. Of course, yeah. Always. If there's any question, you know I'm kidding. I don't think we should drop it unless you just have no earthly idea what we're doing. If you have no earthly idea what we're doing, then don't answer that question because that'll hurt my feelings, and then I'll have to go put smokestacks on my truck because then I'll be very insecure about myself.
I like the direction.
People ask me why I put a brush guard on my truck. I don't know if you noticed, but I put a brush guard on it.
I'll tell you why I put a brush guard on.
Let me tell you why I did first. A lot of people say, you're going through midlife crisis, you're going four-wheeling. No, it has nothing to do with the woods. Anybody have any clue why I got a brush guard on the front of my truck?
I don't know why you got a brush guard, but I know why I got one.
Will you be quiet? The headlights on my truck are what? Plastic. So they break real easy. And when you go and check cows, the cows sometimes don't move. And what happens when a piece of plastic runs up against 1,200 pounds and 1,200 pounds don't move real fast? I've cracked 3 or 4 headlights and I get tired of buying them. So, because then they fill up with water and moisture and then eventually make your headlamp bulb bust. Or, well, bust. Now, why did you put a brush guard? Because we know you don't want to tell us. But
Instead of cows, explorers don't do it. I creamed the rear end of an Explorer over the summer, and the only reason most of the front clip is still intact is because I had the brush guard on that. And so the first thing that I bought after that wreck was the brush guard.
I don't blame you. Actually, this one's given to me, so I can't complain. I just had to pay for it to be put on. I could have put it on, but I really don't like taking the bolts out, putting the bolts in. I really don't like doing that because sometimes these bolts do not come off real easy. So when they're rusty.
I use these big bolts.
Now, have you seen, and speaking of not hitting cars, have you seen the most recent invention that's on TV to save your bumper?
Oh, the WeatherTech.
The piece of rubber that. Now tell me that wasn't ingenious on somebody's part.
I thought it was. I mean, I already do it. Just leave it.
People are going to buy that.
Oh yeah, but it's still.
Oh yeah, but people are going to buy it, and guess what? That the person that designed that is going to be rich.
It does nothing for if you're like going, like if you're driving forward, if the person in front of you doesn't.
Oh yeah, I know that.
But I mean, the cool thing about it is like when you're backing into a parking spot.
Yeah.
I keep.
That happens to my truck. When I back in, I can't see, and I'll back into somebody else's car.
Yeah, see, I keep a metal receiver on my guard my bumper, but then I'll end up taking out the person.
Yeah.
From the front, we were talking before. So the rubber thing's a good idea, and I wouldn't do it if it wasn't like $50.
Yeah. You can make your own.
Yeah, well, I just.
All you gotta have is an old grease hitch, cut off the grease hitch and put you a piece of steel and then put rubber around it. Huh? Yeah, you can do that. Everybody's gonna be running around with pool noodles on.
It's a pool noodle on a truck too.
So see, you should have came out with that and you wouldn't have to be here. You could make millions of dollars. All you gotta do is come up with an idea like that.
I've got one.
Cosine cube of x times the sine of x, or sine to the negative 1/2 x dx. And that's going to be the antiderivative pi over 6, pi over 3, cosine squared of x times sine negative 1/2 x times cosine of x dx. When I saw it, the first time I saw it on TV, I said, okay, somebody's going to make $1 million. The people that make the floor mats, what are they called? The WeatherTech. I got them in my truck too. And I like those, especially with Calmaneer.
Kind of look it up.
WeatherTech. WeatherTech. You can just pull up it on pull up it. Yeah. Pull up it on YouTube. No complicated. All right. Pi over 3, pi over 6. 1. What's the cosine squared? 1 what? Have you started seeing a pattern to these things? And what are you going to do with that? Distribute it? I'm not going to write that. I'll write that later, okay? Sine. Sine of negative 1/2 x cosine of x minus, let's see, that'd be what? 4/2 plus negative 1/2 is what? 3/2, right? When I switch pages, it'll flip it. It'll do it that way. It's a conspiracy. Have you seen in the news where Obama's administration is already implementing the immigration, where they're giving them voting rights and driver's license and tax social security numbers? People don't have no clue. I asked one class yesterday and they're like, "Who's Obama?" 30 students have no clue what I'm talking about. Looks like to me we got it, what is it, UDU, pretty much, except for the negatives.
Dang, where's my notes? There we go. Make sure I ain't got, yeah, sine 3/2, cosine of x. So I get u to the 1/2 of the sine (1/2) x over 1/2 minus sine of 5/2 x over 5/2 evaluated at pi over 6 and pi over 3. That's going to be 2 times sine of 1/2 x minus 2/5 sine 5/2 x evaluated at pi over 6 and pi over 3. I got around, y'all check my math, I got around 0.24. So, around 0.24. When I was taking calculus at Clemson, we had a professor. He was Dr. Harden, and he was a nice advisor and a good guy, but couldn't teach for squat. And he running all the time, and about this tall, and he had white hair, and he wore light blue shirt with dark blue paint, polyester pants, and light brown shirts with dark brown polyester pants. And he would wear those alternating every day. Very nice guy, very good advisor. Good teach for the crowd. And he's running. I don't run it right here, but he would, when he would do something that y'all know how to do, he would, that's what he would say. and around 200 people were in Daniel Hall Auditorium. 200 people taking a Scalp 1 class. He would have his little microphone on and that meant you know what to do. I don't do that, I just put 3 dots. All right. Let's try nerding. This one may be challenging for you. It may look simple. You might want to do it at the top of the page. If you do it step by step.
What did I do? What did I do to start doing this? Up here? This has done this like 3 times. Yep. Hmm? Wow. Y'all know something's gonna happen. It's probably gonna blow up. Make sure y'all cover it. Now you can rewrite the cosine as 1 plus cosine of 2x over 2x. I mean over 2. So you ever have one of those days you just feel right? And that's using a half angle. Hold on. Getting there. Okay. Now, rewrite this using the square. Thing on antiderivative. I can't write one else. Antiderivative of 1 plus cosine 2x quantity squared over what? 4. And guess what the rest of the problem is? Did you just see? What's the rest of the problem? Calculus or algebra? Algebra pretty much. So there's a couple of things you need to learn in this chapter. 1, you need to learn how to find a pattern of U du. 2, you need to remember your identities or have a sheet like I borrowed up the last couple of days and printed out. And 3, you have to remember your what? Your algebra. If you can't do all 3 of those, then you need to what? And live in the ditch. Yeah. What you got here? Dang old shortcut number what? 1. So antiderivative of 1 plus 2 cosine of 2x plus cosine squared of 2x over 4
And keep going.
Don't forget the dx. Absolute value. The antiderivative of 1/4 dx, I'll do that one for you, plus 2 antiderivative of cosine of 2x over 4. I'll pull that 4 out of there too. Dx. Plus antiderivative cosine squared of 2x dx. Say again? I forgot to do what? Oh, thank you. I'll just do it on that page. Right here. 1/4, how about there? Is that good? Y'all hold it down, okay? Trying to teach here. Huh? I told you I'd do this one for you. 1/4 antiderivative of dx plus 1/2 antiderivative cosine 2x dx plus 1/4 antiderivative cosine squared of 2x dx. Thing old 2, you're going to need a 2. Thing old derivative of 2x is 2dx, so you're going to need a 2 in the second one. And you're going to need a 2 in the third one. You can also change that cosine squared of x into double angle again, or half angle. You can do that. Yeah, the third one's going to hang you up a little bit. You need to do it one more time with a half angle. I think you could do the rest of it by calculus. So that'll make this one 1/4 what? I think I know what's happening. Yep. I'm stepping on the cord, and that's causing it to stop. It's causing it to do something. At least I know what's happening. I don't care what happens. I know what's happening. So what's this? 1/4 X? Say again? Yeah, I did that one for you. Huh? Make sure I didn't make a mistake. Plus 1/2. This is 2x, so that would be a 2 out here, which would be what? Right? 2 would be 1/2. So that would be the derivative of the cosine is the antiderivative of the cosine is the what? Times 2. What's the antiderivative of cosine? The sign, the positive sign, right? Plus 1/4. This one, see the 1 plus the cosine of 4x. Okay. 1 plus the cosine of 4x over what? 2 dx. Now finish that one. And that 1/2, you can break it up, and cosine of 4x dx over 4 will be 1/4 out front. So that would be cosine squared over 2. And then that 1/2 can come out. So after you do 2 or 3 more steps, I think I've got an error on the first one, unless I missed something. Hold on. 1/4 x plus that'd be 1/2 right here. Because we had to put a 2 here. 2 dx. That'd be 1/2. So that'd be 1/4 sine of 2x plus, when you get through with this guy, no. 1 over 32 sine 4x plus c. Yeah. Challenging problem. I wouldn't give you one that long on the test unless I was going to give you just 2 or 3 problems. So, unless I just didn't like y'all. If y'all want to talk to me, so. Could hold that against you. Look at a couple more out of the book, just to give you a good, because a lot of your test questions are going to come from. Let's try one of the, mostly the last one we did was 17. Let's try, I got a tangent in here, tangent to the fourth. There's a tangent to the fourth. Let's try 31. Tangent to the fifth x dx. Tangent to the fifth tangent to the fifth x dx. And you can take a clue from this one right here to right here. Might help you out. Tangent is 1 minus the what? Or secant squared minus what? 1. So antiderivative of the secant squared of x minus 1 quantity squared, and that's shortcut number what? Actually, it's number 3. Because it's different. No, my bad. Shortcut number 2. A minus b quantity squared times the tangent x dx. And that's going to be the antiderivative of secant to the fourth x minus 2 secant squared of x plus 1 times tangent x dx. And of course, I'm going to distribute that.
And you'll start seeing the UDU pattern.
So the antiderivative of secant to the fourth x tangent of x dx minus 2 antiderivative secant squared x tangent x dx plus the antiderivative of tangent x dx.
That's secant to the fourth. You can break it up. Secant squared. Quantity squared. You sick, Mr. Fowler? We don't want you to be out in. So we have UDU. I didn't even think about that. Yeah, I did. I'd do U to the fourth, U to the fifth. No. Yeah, let's secant to the fourth. We're not ready for it yet. Because that would be, yeah, a couple more steps. Today's Tuesday, right? Mr. Alexander's, I don't think he's ever gotten over his sickness yet. Mr. Bowling's here. Corwin's here. Fowler's here. Mueller? Osland is not here. Robinson? Urban, not here.
Vaughn, Williams, and Wiseman. One, two, three, four, five. Got five missing today. All right, that secant to the fourth still isn't what we wanted. So we need to rewrite it to where we can get some kind of UDU. And that is secant cubed, secant tangent. So antiderivative of secant cubed, secant tangent, and that'll help us out a little bit, minus 2 antiderivative secant squared of x tangent x dx plus antiderivative tangent x dx. I doubt I'm going to be able to copy all that. Now, that secant tangent, that looks a whole lot better now, doesn't it? I think we can pretty much take the antiderivative now, can we not? Finish it out. So secant tan is the derivative, so that will make this u to the fourth over 1/4. So that'd be secant to the fourth x over 4, which would be 1/4. You can pull that out. Minus 2. And then what do we get here? We're going to get u to the what? What do we got here? Huh? U du, right? So that would be 2u, but I thought we were going to cancel out. Huh? I thought that 2 canceled. Be u squared over 2, yeah. U squared over 2. Secant squared, sorry. I was thinking secant squared x over 2, and those cancel. Plus, and what's the antiderivative of the tangent? Secant, natural log of the secant. Plus C. That 1/4, you can bring that out. 1/4 secant for x minus secant squared x plus the natural log of the secant of x plus c. So manipulation. Rewriting and manipulating. Know 3 things. U du, know the patterns of U du, know your reciprocals, and know your algebra. And that's 7.2? I think next is trig substitution, right? Yeah. And we'll go over that Thursday. Y'all get out of here. Have a good day. Try to be discouraged. Huh? Oh yeah. There ain't too much enjoyment at the dentist. Even the waiting room's depressing.